Hello and welcome to Module 7 on series, data frames, and tidy data. So far we've finished the Orientation in Python Foundations cluster, or C01, in which we've seen basic Python, that's variables, types, control flow, and functions. We've scratched the surface on doc tests and even gotten our first taste of debugging. Now we're going to go deeper into one of the preeminent and most popular libraries for data science in Python. That's pandas. We've already been using pandas quite a bit in previous modules, and going forward this is going to be the main tool that we're going to see for tabular data. I want to mention that all of this kind of is a step-by-step service of our long-term goals. So in real data science work, most of what we're going to be doing is a kind of fancy machine learning models, and we're going to focus on experimentation around those. But in order to do that, we're going to need to train those models from data, and in order to get those data in a form that's configured properly and pre-processed correctly, we're going to have to do a lot of data wrangling, and that data wrangling is going to be done in usually with pandas. By the end of today's module, you're going to be able to explain the difference between series and data frames. You're going to be able to construct small series and data frames from lists and dictionaries, or dicts. You're going to be able to use head, shape, columns, and index to quickly inspect a data frame. You'll be able to explain what a tidy data means, generally in which each variable refers to a column, every observation is a row, and kind of a unit of understanding is a table. And you'll also be able to recognize when a table is not tidy, and you'll even be able to kind of describe how you'd be able to fix it, even if you don't necessarily have the code to do that just yet. So some tables in the wild. So real projects that you might work on could include things like analyzing bike share trips in a city. So a bike share might care about identifying individual trips using an identifier, measuring the start time and the end time, measuring the start station, the end station, maybe incorporating something about the type of user. So are they a user that subscribes, or are they a one-off user? Maybe they paid for the trip and you want to record the price. Maybe there are other variables as well, but this is basically one description of bike sharing trips. Maybe you're a data scientist working at a hospital and you want to track patient vital measurements as they are in a hospital. You obviously want to keep track of the patient ID. You want to record a date or even a time when the vitals were taken. You want to measure systolic and diastolic blood pressure, heart rate, many other potential vitals as well, and store this all inside of a big a unit of data. Maybe you've developed an app that tracks wellness. So you might want to track daily steps, you might want to track sleep. So to do that and to incorporate data from many users, you'd want to identify different users. You'd want to record the date, maybe time. You'd want to measure the steps taken, like we've been doing quite a lot of. You might want to measure the number of sleep in terms of hours. City can be important. So we had a paper that we published several years ago where we basically had a machine learning model that estimated a measure of wellness based on where people lived, because where people live changes your latitude, changes the time zone you're in, and then therefore changes the number of daylight hours you get. So the number of daylight hours you get per day can affect your wellness, so maybe you want to include some other information there. And a ton of other information around quantified self-wellness. All of that would be incorporated in another large chunk of data. So what are these chunks? Usually they're going to be tables. So we're going to have lots of rows. These rows are going to be records, and the columns are going to be variables, some of which we've just mentioned a moment ago. So pandas is basically one way of having a language for working in tables in Python. Let's see pandas in one slide if we can. So here's a quick definition for you, a quick mental model. So this is kind of important. A series, as the name kind of suggests, is one-dimensional. This is a labeled vector of values. We've already seen lists, but those lists, like the list of minutes studied in Module 4, are just going to be unlabeled, unnamed values. We had a list of minutes, but all we had was the individual numbers for every element of that list. Lists can also be thought of as vectors. We're going to talk a lot more about vectors in upcoming modules, which I'm very excited about. But usually those aren't labeled either. The main thing that makes a series is that these vectors of different values have labels associated with each of these values. A data frame, by contrast, is a two-dimensional table, mostly consisting of series, but these series are aligned with one another. So it can be considered that every row of a data frame is a series, and all of these series are just kind of aggregated or concatenated together into one two-dimensional object. We have a lot of one-dimensional objects all stacked together, gives us our two-dimensional data frame. Every series in data frame will have an index. These are like labels for rows, and usually, but technically optionally, but also ideally, you'll have names for columns and series. So let's just see a bit of code quickly. We're going to, again, import pandas. We're going to rename it PD for efficiency's sake. And now we're going to create a series object. So the series object has a list. It's a one-dimensional object. Here this list is going to be step counts, just integer values. Every element of this list is going to be associated with a label. In this case, we call it index, and here are the labels for that index. So the first value, 8,123, has the label Monday, 10,450 has the label Tuesday, and so on. This entire series has the name steps, and that's more or less it. So when we essentially print out this series on line 8, we get the list, we get the index name or the label, Monday, we get its value, 8,123, and so on for each of our series elements. We have the overall name for the whole series, and then we also have the D type, the data type, for each of these elements, in which all of them are integer values stored with 64-bit precision. So for now, you might want to think as a series is sort of like a column with labels, and a data frame is going to be the whole table. So here again, data frames as tables. So here's some additional code. We have pandas, again, being called PD. We have some data. This data is a dictionary. It's a dictionary because we have these curly brackets. A dictionary is a bunch of key value pairs like we talked about earlier. So here the keys are user ID, city, and steps, and their values associated with each of these keys we obtain just to the right of these colons. So the value of user ID is either 101 or 102 or 103. The values of city are provided in this list. They're the string Halifax or Toronto, and so on. We can take this dictionary data, we can pass it into the function from pandas that creates the data frame, store that in the data frame, and then just return it, and then that gives us this object over here. So here's, again, we've seen data frames before. We have our rows, which are our individual data points. We have our columns, each labeled, user ID, city, steps, and so on. You can do some inspections, so I don't do that here exactly, but I welcome you to and encourage you to copy these lines of code. These will return the shape of the data frame, the columns or the column names of the data frame, the index labels, which in this case are going to be the default labels, and then head. We only have 3 rows of data here, so head, which normally by default returns the first 5 rows, will just return the first 3. But run it and make sure that what I just told you is true. So here's a little tip. We've kind of done this a little bit before, but I kind of like, whenever we load data, I like kind of saying hello to the data. And there's a couple of ways of doing that. I often use head to do so. Head will just kind of print up, like I mentioned a moment ago, the first 5 rows of the data. But this is just helpful to ensure that the data looks the way we kind of expect it to. So the columns are nicely organized, the rows are organized, the data itself, even though I'm only looking at the first 5 rows, more or less makes sense, and it kind of helps me get a clear mental model of how the data are arranged. This is just helpful because sometimes you have to load data from a file without looking at it into a data frame without looking at it, and you just like peeking in and seeing what's what. So it's kind of like saying hello. So normally when we load data, whether it's from a dictionary or from a file, it's a good idea to run ahead, see what's there, and take a look. So we're going to just quickly talk about series versus data frames. So here we again create our series, and like we did a moment ago, here we're going to then take the steps and convert it to a frame. So convert it to a one-column data frame. Steps is just going to be a series. It's one column of data with an index. DF steps, which we obtained on line 7, is a data frame. This is still one column. I know I mentioned data frame is generally going to be two-dimensional, but here it's two-dimensional, but one of those dimensions is very short. It's just cardinality of one column. But we can still add more and more columns, like sleep and city and so on. And just a bit of a disclaimer, many pandas functions will expect you to pass in a data frame by default. Sometimes some functions, if you pass in a series, because series can be thought of sometimes as a special one-dimensional form of a more general data frame, it's very easy for pandas behind the scenes to convert a series into a data frame. You can't always assume that, but it does occur occasionally. I want you to take a moment and just jot this down, when you might consider it to be enough to use a series, and when you might want a full data frame, right? But regardless of what I mentioned a moment ago about the fact that some functions assume data frames, is there some conceptual reason why you might prefer to use a data frame, or where you might want to just use a series based on what you know already? Tidy data. So tidy and tiny data are different ideas. You can have a tidy data set, which is nevertheless very large. There are multiple ways of thinking of tidy data. We're using one from Hadley Wickham, whose site you can find here at this link. And this is something that a lot of other people have been using, and we've been using ourselves too, but the idea is we have different variables in our conceptual unit or our data frame. Each of these variables is represented in a column. Every observation we have, or every datum we have, if you want to sound fancy, but it means the same thing, is going to be a row in our data frame. And then, our observational unit is going to be our table. So we talked about that earlier too. So an example in our daily app of wellness is here. This is a tidy example. So we have user IDs, dates, cities, steps, and sleep hours. And each of these variables is a column. And every observation we have here is a row of data, right? So we have two rows for user ID 101, but one of them was taken on September 1st, another one on September 2nd. So these are technically two different observations for this user. A messy example is messy in a few ways. Usually, but not always, messy examples are sort of wider. So here we decided I'm going to compress things by user, and I want every row to be an individual user of my app. But to do that, you're going to have to compress or like spread out all of the information about the dates and the steps and the sleep hours across columns for this one row for this one user. So here I have to have, one column is going to be just the steps taken on September 1st for all of my users. Another column is going to be the steps taken on September 2nd for all of my users. I get another column, all the sleep for the first measurement, all the sleeps for the second measurement, and so on. And this is the toy data. Already this is getting kind of long. Already this barely fits on the slide, but you can imagine if you're measuring, steps and sleep and maybe other variables for every day, you can see how this table is going to extend rightwards well off the slide, and we're going to be pretty upset. And more or less, you're also going to have to keep on adding these very specific column names, which is just kind of messy. And already you can see it's a lot easier to kind of conceptualize of what's going on in the first table. And again, this breaks one of our first rules of a tidy data set, which is that every row should be a single observation. And if you're building an app in which you want to observe the daily habits of your users, then a snapshot of that day should be the row. The user ID, and in that observation you have information about that user's steps, sleep hours, and so on for that day. Okay? So think in terms of a compressed number of variables, and every row is an individual observation at whatever granularity your use case prescribes. So again, we have the same information. The tidy data set here on top and the messy one on the bottom has the exact same numbers, and so you can extract the same useful information from each of these tables. But not only is the tidy example a bit conceptually easier, it's also functionally easier to filter the information, to group the information, to visualize the information, and feed the information into models. Bit of a side note: occasionally I use British spelling. So Canadian spelling, which is with the purpose of our course. So occasionally we use Z's for things, sometimes we use S's. So it's not a spelling mistake. It's just the day that I made these slides, I was feeling more British, so we were using the British spelling. Here's a case study: student stress and sleep. Here's a realistic-ish, mini, small toy data set. So imagine we're doing a study on campus. Imagine you're trying to help the wellness of other students at your campus, assuming you're watching this on a campus. I'm building this for people in this class, so that should be a good assumption. Our students in our study are going to log their sleep hours and their stress level, this new variable, every day over the course of 2 weeks. And then we want to kind of study, is there some relationship between their sleep and their stress level, but also we want to break things down according to their program. So we have information about this user is in computer science, this one's in biology, and so on. We also know what year they're in first year, second year, and so on. Okay, maybe there's some kind of relationship between the year they're in and their stress level, right? Maybe your hypothesis beforehand is that first years might have more difficulty managing their stress, but hopefully as they get into second, third, and fourth year, they've developed some techniques that can manage their stress, even under varying sleep hours. So a tidy table could look like this. We have a student ID, we have a date. Again, the unit of measurement is a day of information. So this student ID 201, we have information on September 1st and September 2nd. Their program's not going to change. There's a bit of redundancy there. The year is not going to change. Again, some redundancy. We might be able to see some ways around that redundancy later. But regardless, on the first, they slept for 6 hours and have a stress level of 7. On the second, they slept for 7.5 hours and have a stress level of 5. So we can already answer some pretty easy questions from this tidy data set. We can get averages about how many hours do first year computer science sleep. We can compare the average stress, which we can compute similarly. We can compute whether it's higher on weekdays or weekends. I mean, we don't have the label weekend or weekday here in this table, but we can extract that from the date column. Then we can do an average of stress level in each of these different groups and compare them. We can also look at over all of our students, all of our users. We can look at their sleep hours. We can look at days in which the hours were less than 7 hours, and then we can compare the level of sleep these students are getting to their reported stress level, and this will help us answer the hypothesis of is there a relationship between sleep and stress, which we kind of might assume that there is. So later on we're going to actually use pandas to run these summaries, but for now we're just putting a pin in it. So we're going to talk about wide versus tidy steps as an example. So here's some code to generate a nice data frame in pandas. We have, nice. It's a wide format, right? So we have a user ID. Again, this is what I called messy previously. This is the long across columns format. We have a number of steps measured on Monday and on Tuesday and on Wednesday for each of our users. This is okay if we care about one person per row. We want to summarize things per person. And maybe at some point this view is what we want on our data, if we can somehow summarize the columns effectively so that it can fit in a form that's relatively tight like this. And there are ways of transforming tidy data frames into a long format or a wide format like this. But it might be awkward if we try to average steps per day of the week. We have maybe multiple iterations of Mondays, multiple Tuesdays, multiple Wednesdays if we keep on measuring data for these users. And if we wanted to average steps per day of week, we're going to have to kind of dig into all the columns, extract those columns referring to Mondays, and then average those and do all these extra steps. It's also going to be kind of difficult to do line plots of steps per day as these tables get wider and wider and wider. Tidy might be a bit easier. So here we have a tidy version in which we have individual observations per row. Every row represents a particular version of these days. So on one Monday, there was 8,123 steps. On another Monday, there was 10,450 steps for user 102, and so on and so on and so on. So now we have one row per user ID and day together. We have a single steps column, so we don't have to have multiple columns with steps kind of arrayed all over the place. And this will be able to help us get all kinds of statistics out of the table much more directly. We're going to be more systematic about reshaping this table in Module 10, but it's useful just to see the comparison between the wide table here and the tidy table here. We just want to check some understanding here. So in tidy data, what does one row represent? If you see columns like temp morning, temp afternoon, temp evening, what might you assume a tidy version might look like? For the step tracking app we have previously, would you store city as a column or split this into multiple different tables? And why would you do that, or why would you not do that? All of this is to jot down and take into class. You don't need to memorize British spelling again. Every pandas method we've included yet. I just want to kind of, the whole point of this module is just to separate the idea of a tidy table with kind of a more messy or wider table more generally. So that's all for this module. Looking ahead within this cluster of cluster 2 and pandas. In Module 8, we'll load some real data sets using CSV files and JSON files. We'll describe them. We'll get info from them. We'll talk about data types. In Module 9, we'll talk about indexing, selection, Boolean masks. Then in Module 10, we'll talk about group by, aggregations, windows, pivots, and reshaping. Module 11, we'll talk about bigger pandas case studies. So that's what's to come. After this module today, I just want you to be comfortable with the idea of series versus data frames. I want you to be able to understand whether a table is tidy or messy, and also maybe conceptualize a little bit about why that difference might matter. And I would like you to be curious about how one might transform messy tables into a tidy version. Even if, again, the code to do so might be new to you, just think about how you might want to do it conceptually, and if you're feeling a bit more adventurous, try to write some code to convert some of the messy tables we've seen previously into a tidy form. Thanks so much. See you next time.